All right, we're here in section 6.3, and now we're going to be looking at how to divide polynomials. In this first video, we're going to look at doing it with long division. Okay, so let's just get right into an example here. We're taking a trinomial of x squared minus 2x minus 15. We're dividing that by a binomial of x minus 5. Okay, now the x minus 5 is your divisor. So we're gonna put the divisor outside of our quotient bar, just like we would for long division of real numbers, okay? And then x squared minus 2x minus 15, this is your dividend, it goes inside, all right? Now, here's the question that I ask myself. I always want the leading term of the dividend to get canceled out. So in this case, the leading term is x squared. So I ask myself, what should the divisor of x minus 5 be multiplied by so that at the very least I get an x squared to result, okay? And the answer in this case is x, all right? So I'm going to place an x up here for the start of my quotient. And just like in regular long division of real numbers, whatever you put up there has to be multiplied by the divisor. So x times x minus 5 will give you x squared minus 5x. All right, and again, just like regular long division, you're going to subtract here. Now, since I'm subtracting a binomial, I like to put parentheses around the binomial to show that I need to distribute that negative, okay? So what happens now is the x squareds cancel, that was my goal, and then negative 2x subtracted by negative 5x is 3x. Be very careful about your signs there, okay? Now, since you canceled out a term, you need to bring the next term down. And now the process starts over. Now I ask myself, what should the divisor be multiplied by so that I can cancel out 3x? And that would be a positive 3. 3 times the divisor of x minus 5 is 3x minus 15. I'm going to subtract here again. And notice both of these cancel out to where I have a remainder of 0. Okay, so that tells me the quotient from this long division process is simply x plus 3. Okay. Now, anytime the remainder in long division of polynomials is 0, it tells me that more than likely the polynomials that I was working with in the original division process are actually factorable. Okay, so here it actually would have been another approach you could have taken. Think of division, you could write that as a fraction, right? And then that numerator, that quadratic, is factorable to x minus 5 times x plus 3. And notice, once you think of the factored form, you can reduce away the x minus 5s, and you're left with x plus 3. So there's an alternative approach, but again, it's only going to work when the divisor or the dividend are factorable. Okay. All right, second example. This one is a little bit more involved, and it's presented to you as a multiplication problem. So notice I have the first polynomial is being multiplied by 4x plus 3, but to the negative first power, okay? So here's where property of exponents comes into play. I know that when I have a negative exponent, I can turn it to being positive by putting it down into the denominator, right? So this can really be rewritten. Excuse me. So now that 4x plus 3 can be thought of as that whole binomial raised to the positive first power, okay? So Again, we're really working with the division problem here, even though it was presented as a multiplication problem. All right, so let's set this up. 4x plus 3 is your divisor, your dividend, 16x cubed minus 24x squared minus 11x plus 12. And the goal is the same here, trying to cancel out the first term of the dividend, right? So what can 4x plus 3 be multiplied by to create a 16x cubed? And that would be 4x squared. 4x squared times 4x is 16x cubed, and then 4x squared times 3 is 12x squared. Subtract, those cancel. Negative 24x squared minus 12x squared is going to give you negative 36x squared. Then bring the next term down. Okay. Now the process starts over. The goal is to cancel out negative 36x squared. To do so, you're going to need to multiply by a negative 9x into your divisor. So negative 9x times 4x gives me negative 36x squared. Negative 9x times 3 gives me negative 27x. And we subtract. Those will cancel out. Negative 11x minus negative 27x is 16x. And then bring your final term down. Now we try to cancel out 16x. To do so, we're going to multiply the divisor by 4. That's going to give me 16x plus 12. And all of that cancels. So my quotient is that resulting trinomial at the top there of 4x squared minus 9x plus 4. Okay. All right, now let's get into an even more complex example. All right, so here the polynomial, our dividend it's got 4 terms, and then your divisor has 2 terms. And one thing I'm noticing, if you look at x plus 4, or I'm sorry, x to the 4th power plus x squared, see how you skip a power of 3 on x, all right? That's a big deal, all right? That means when I go through the long division process, if I don't account for a power of 3 on x, I'm not going to get my terms to line up by power, which will be a problem, okay? And then I actually have the same thing happening here in the divisor. You jump from x squared down to your constant of 2, you're missing a term with a power of x or a power of 1 on x, all right? So this particular problem is going to require what we call placeholders. All right, so here's going to be my setup. The divisor needs written as x squared plus 0x plus 2. So this 0x is considered a placeholder. Okay, and then my dividend needs to be written as x to the 4th plus 0x cubed plus x squared minus 3x plus 5. So the 0x cubed is also a placeholder. Okay. All right, now that I have the proper setup, my goal is to cancel out x to the 4th. So I'm going to multiply the divisor by x squared to do so. That's going to give me x to the 4th. Then x squared times 0x is 0x cubed. X squared times 2 is 2x squared. Okay. I'll subtract, cancel as well, and then x squared minus 2x squared is negative x squared. All right. Now notice how I got 2 sets of terms to cancel. So that means I need to bring 2 terms down this time. And now the goal is I want to cancel out negative x squared. Okay, so to do that, I'll multiply by a -1 with the divisor. So -1 times x squared is negative x squared. -1 times 0x is 0x, and then -1 times 2 is -2. All right, so those cancel out, and you're left with -3x plus 7. And notice there's nothing left to bring down. So this -3x plus 7, this is your remainder. Okay. This is the first example where we've had a remainder. And you're going to use the remainder the same way we would for long division of real numbers. Okay. So I'm going to go up to the quotient, and I'm going to add on my remainder over my original divisor. Okay. So in the end, this is my quotient, this whole expression here. All right, one final example. Here we have a polynomial, it's a trinomial that's being divided by a monomial. All right, now notice the directions here. When dividing by a monomial, we don't have to use long division. Okay, do not use long division. It's not going to be necessary. So here's how I would approach this one. Take each term of the trinomial from your numerator and write it separately over the denominator. Okay, so what I mean by that is let's make this 5a squared b divided by 5ab minus 15ab cubed divided by 5ab plus 10a cubed b to the fourth divided by 5ab. And then for each of those fractions, you can just apply some properties of exponents. So those will reduce, those will reduce. You'll just be left with a squared over a, which becomes a. All right. Then 15 will reduce to a 3 if the 5 reduces to a 1. These a's reduce. This will become b squared, and that'll reduce away. So that leaves me with 3b squared. Then plus, let's see, 10 will reduce to a 2 if the 5 reduces away. A cubed will become a squared if the a reduces away. And this will become b to the third if b reduces away. So I end up with 2a squared b cubed. And this is my resulting quotient. Okay. All right, so now it's your turn. The problem on practice 1 here, it follows a similar format to example 3, okay? So if you get stuck at any point working through that on your own, come back and check with example 3, okay? Pause the video, work through it yourself, and then come back and check with my work.